Hi ladies, this is lesson 3.8, and this is about constructing points of concurrency. You'll have to do this constructing in your homework, but this lesson is mainly about vocab terms. So we're going to look at what kinds of points of concurrency that we need to identify given particular examples, but first, again, we have to just define these definitions. And then we're going to explore relationships between points of concurrency and inscribed and circumscribed circles. So if you remember from last chapter, we had a circle circumscribed about a polygon. So let's use a triangle because this lesson deals a lot with triangles. So if this is our triangle, then a circle circumscribed about the triangle is going to be, it's going to touch each vertex of the triangle. Okay, so this would be a circle circumscribed about the polygon. It touches each vertex of the polygon. And then a circle inscribed in a polygon so here's our circle, and again we're just going to use a triangle because that's what we deal with in this lesson. A circle inscribed in a polygon means that the circle touches each side of the polygon exactly once. Okay, so this is a circle circumscribed about a triangle. And this is a circle inscribed in a triangle. Okay, so these two you're going to need mostly for your application problems at the end of the lesson. But for now, just as a refresher, this was in chapter 2, but a circle circumscribed about a polygon touches each vertex one time of the triangle, and a circle inscribed in a triangle touches each side of the triangle exactly once. Okay, so we've got a few new vocab terms: concurrent, incenter, circumcenter, and orthocenter. The first one is concurrent. And here we're going to talk about specifically points of concurrency. So a point of concurrency is the point of intersection. So if 3 lines have a point of concurrency, it means that they all intersect at the same point. All right, we've got a few conjectures, and these are about concurrency. And actually this first one, angled bisector, this should say concurrency conjecture. Angle bisector concurrency conjecture, it should say. And this says the 3 angle bisectors of a triangle meet at a common point. That means they are concurrent. So that's 3 angle bisectors share a point of concurrency within a triangle. The perpendicular bisector concurrency conjecture says the 3 perpendicular bisectors of a triangle are concurrent. And then the last one, altitude concurrency conjecture, is the 3 altitudes, or remember with obtuse triangles, our altitudes lie outside of our triangles. So the 3 altitudes or lines containing the altitudes of a triangle are concurrent. So we'll go over how to actually construct these, or what these actually look like in just a second. But again, this is about concurrency. So angle bisector concurrency conjecture, perpendicular bisector concurrency conjecture, and altitude concurrency conjecture. So all of these concurrency conjectures say that the altitude, the perpendicular bisectors, and the angle bisectors are all concurrent within a particular triangle. All right, this next one, the point of concurrency for the three angle bisectors, we call this the incenter. So this is a key vocab term that you need to know for geometry. The incenter is a specific point of concurrency. So if you think of a Venn diagram. Okay, here's our diagram, and this is about all of the points of concurrency. So with anything, not specifically triangles, but so within points of concurrency, we have a group of points that's the incenter, and then we have two other groups that we're going to identify in just a second, but we'll name them on here. So incenter is a specific group of points of concurrency. It's a point of concurrency of the three angle bisectors. Then we also have the circumcenter, and we also have the orthocenter, which we will define these in just a second. So the incenter specifically is a point of concurrency for the three angle bisectors. Okay, so let's look at a triangle for a second. So here's a triangle, and I'm looking for the three angle bisectors. All right, so if I bisect this angle, I'm just going to sketch this out for now. In your homework, you'll actually do a little bit of constructing, but for now, I'm just going to sketch it out. So the angle bisector, and my angle bisector. Okay, so this point here, right here, this is called the incenter. So it's a point of concurrency, but it's specific. It's a point of concurrency for the angle bisectors. Okay, the second one is a point of concurrency for the perpendicular bisectors. And this is called the circumcenter. Okay, so again, if you think of a triangle, here's a triangle. And I want to find my three perpendicular bisectors. So here's one. This looks like about the halfway point. I'm just sketching it, so it's not going to be perfect. On your homework, you will actually use a compass. All right, so that's my first perpendicular bisector of this segment here. And now I'm going to bisect this one of the sides. So this looks to be probably about the halfway point, and it has to be perpendicular. Okay, so see how they don't intersect? That means I need to make one of mine longer. So I'm going to stretch this perpendicular bisector out. All right, and then my third, this is probably about the halfway point. Here's my perpendicular bisector there. This point of concurrency right here is the point of concurrency of my perpendicular bisectors. So that is my circumcenter. Okay, and then my next one is the point of concurrency for the 3 altitudes. So again, it's a point of concurrency, but it's specific, talks about the altitudes. And this is called the orthocenter. So again, I'm going to look at my triangles. Here's my triangle. And I'm going to construct the altitudes of this. So the altitudes, remember, go from a vertex and it's perpendicular to the opposite side. Okay, so I'm going to go from the vertex and I'm going to make it perpendicular to the opposite side. From the vertex, perpendicular to the opposite side, so it's not necessarily a bisector. It might be if it's an isosceles triangle, but not necessarily always. It just goes from the vertex, perpendicular to the opposite side. So this point right here, that's my orthocenter. Okay, we've got a couple conjectures that go along with these definitions. So the first one is the circumcenter of a triangle. And the circumcenter of the triangle is equidistant from the vertices. And the second one is the incenter conjecture. The incenter of a triangle is equidistant from the sides. So if you look at the 3 angle bisectors and the incenter, and then if you look at the 3 angle bisectors and where they meet, that point of concurrency, again, we call that the incenter. And then the incenter conjecture, it says the incenter of a triangle is equidistant from all of the sides. So that means here, this segment here is the same, oops, not the segment. The perpendicular segment from here to this side would be the same distance as okay, so this perpendicular segment from here to here is the same distance as perpendicular segment from here to here, and is the same distance as the perpendicular segment from here to here. So all 3 of those blue segments, those are the same. Remember, we measure distance using perpendicular segments. So the incenter, this point of concurrency with the 3 angle bisectors, is equidistant from each of the sides. And then the second one, conjecture that we have, well, actually the incenter was the second one from your notes, but this next one, the circumcenter conjecture, the circumcenter of the triangle is equidistant from the vertices. So the distance from here, from the circumcenter to the vertex, the circumcenter to the vertex, and the circumcenter to the vertex, all of these 3 lines are congruent. Congruent, congruent, and congruent. So the circumcenter of a triangle is equidistant from all of the vertices. So that's all for lesson 3.8. Again, it's a lot of vocab, and on your homework you're going to have to actually apply and construct some of these vocab terms. But really do something to remember these words, whether you put them in Quizlet or make a list or highlight in your notes or something, to keep all of these vocab terms straight. And please jot down any questions you have and we can go through them in class. Thanks.